Good morning students. Welcome back to our science class. Today we are going to study a new chapter, chapter number 11, force and pressure. We all know what is a force, right? At least in the literal meaning we know what is force. When I am trying to push something or trying to pull something, we can say I am applying a force. Okay, when I am trying to push something or when I am trying to pull something, we can say that I am applying a force. Okay, when we are talking about the force, that is when we are discussing about the definition of a force, we use two types, which are the push and pull. And what do you mean by this push and pull? Push means a force applied to make an object move away from oneself. Push means we are trying to move a body away from oneself. And pull, a force applied to bring an object closer to oneself. When we are trying to, when we are applying a force to bring a body closer to oneself is called pull. And I will make it more clear. A figure is given in your textbook, page number 187. Figure A. Here in the case of first figure, a man is trying to move that body away from himself. Okay, away from himself, then it is push. The first figure, he trying to move that body away from himself, that means push. And the second figure, he trying to bring that body closer to himself or trying to move the body close to himself, then it is a pull. So whenever we are trying to make a body close to ourselves, then it is called a pull. And whenever we are trying to make an object move away from oneself, then it is known as push. Therefore, the definition for a force is a push or pull on a body is called force. Okay, force means a push or a pull on an object is called a force. When I am trying to move something by applying push, by pushing or pulling, then we can say that I am applying a force. Okay, the term force is related to push and pull. Push means a force applied to an object to move away from oneself. Whenever we are applying a force to move a body away from ourselves, then it is called push, and the force applied to bring an object closer to oneself, then it is called a pull. It is more evident when you are looking into the figure given in the page number 187. So, force means a push or pull on an object is called the force. So, now we get an idea about forces. Actually, forces are used in our everyday actions like pushing, pulling, lifting something, twisting, stretching and pressing. For example, when we are kicking a football, here we are applying a force, and when we are twisting a wet cloth, and when we are pulling a door and lifting a bucket of water from the floor and stretching rubber bands, all these cases we are applying forces. So forces are used in our everyday life actions like pushing, pulling, lifting, stretching and pressing. When we are driving a car, we apply brakes, right? There we are pressing the brakes. In that cases also we are using or applying forces. All these cases we are applying forces. Okay. Next one is force is due to an interaction. Suppose if you are standing behind a car and you are shouting at the car, will it move? No. And if you are near to a bucket and asking the bucket to come with you, will it come with you? No. Here you have to apply a force. To move a car, you have to push the car, or to lift a bucket of water, you have to apply a force. There should be an interaction between two bodies. Right. So, there is an interaction of one object with another object that results in a force between the two objects. And you are shouting at the car and it didn't move, but when you are pushing the car, there is an interaction between your hand and the car. As a result, the car moves. So interaction is very important. There should be an interaction between two objects for the force to come into play. So interactions are very important. There should be an interaction between two objects. Then only the force come into play. Interaction is the important factor. And when we are lifting a bucket of water, you have to apply a force. There is an interaction between your hand and the bucket. So interaction is very important. Next one is force has magnitude as well as direction. Actually, magnitude means the amount of force applied. Magnitude means the amount of force applied. And imagine that an adult person and a child trying to move a body. Suppose a child and an adult person are trying to move a body, and the adult can apply a large amount of force and the child can apply only a small amount of force. And imagine it is 5 Newton and it is 2 Newton. The adult applies 5 Newton force and the child applies 2 Newton force. Here, this 5 Newton and 2 Newton are the magnitude. Magnitude means the amount of force applied. Here, the largest amount of force applied is by the adult person. So, magnitude is the amount of force. Here, the magnitude is 5 Newton and 2 Newton. And here, the Newton is the SI unit of force is Newton. We know that we measure length in centimeters, meters and kilometers. Here centimeter, there kilometer, centimeter, etc. are the units of length. Same way, the SI unit of force is Newton and its abbreviation is capital N. Magnitude, the term magnitude means the amount of force applied. Here the amount of force applied is 5 Newton and 2 Newton. Then what about the direction? Suppose I am trying to push this body and I am applying a 5 Newton force. Here the 5 Newton is the magnitude and then I am applying force in this direction. That is, the force has a direction and it has a magnitude. And when I am trying to move this body in this direction, which means the force has a particular magnitude and it has a direction. Like here it is, suppose the force is 2 Newton, it has a magnitude, which means a value or an amount of force is applied and it has a direction. That's all. Force has magnitude as well as direction. Magnitude means the amount of force applied. Here it is 5 Newton and 2 Newton. Therefore 5 and 2 are the magnitudes and the directions. Force has a magnitude as well as direction. And the next one, imagine that two forces are applied on a body. Suppose this is the body and you are applying a force in this direction and you are applying a force here. That is applying two forces on the same body. Then there are two cases. First one, applying forces in the same direction and second one is applying forces in the opposite direction. Here the first one, if the two forces applied to an object acting in the same direction, if we are applying forces in the two forces in the same direction, then the resultant force acting on the object is equal to the sum of the two forces. When we are applying forces in the same direction, then the resultant force is equal to the sum of the two forces. Okay. And I hope all of you are moving benches in your classrooms, right? Whenever you are applying a force, it will move. Imagine that if the bench is very, very large, then you can't move it and you seek the help of your friend and you and your friend pushes the bench in the same direction. The pushing force is applied by you and your friend is in the same direction. What will happen? You can easily push the bench. Why? Because are applied in the same direction. Therefore, these two forces are getting added. Your friend force and your force and your friend's force are added up. That's why you can easily move your bench. Both of you are applying the forces in the same direction. Suppose you are moving the bench in this direction. You are applying a force and your friend is applying a force, and both of you are applying a total force, and as a result you can easily move the bench. Here the force is applied in the same direction, therefore the forces are getting added up, or the sum of the two forces are applied there. If the force is applied in the same direction, then the resultant force will be equal to the sum of the two forces, and you can easily move that body. And if two forces act in the opposite direction, then the net force or the total force acting on the object is equal to the difference between two forces. Imagine or suppose you are applying a force in this direction and your friend applying a force in opposite direction, that is just like this. You are applying a force in this direction and your friend is applying a force in this direction, that is in opposite. Both of you are applying forces in opposite direction, and imagine that your friend is stronger than you, then he will apply more force, and what will happen? Here that net force acting on the body is equal to the difference between the two forces. What will happen? When both of you are applying forces in the different direction, the body will feel a force, that is the difference between the two forces. Okay. So when your friend is applying a large amount of force, therefore the body will move in accordance with the direction of force applied by your friend. That is, if two forces acts in opposite direction, you are applying a force in this direction and your friend is applying a force in this direction, and the large amount of force is applied by your friend, therefore the body will surely move in this direction. Here that body experiences the force that is equal to the difference between two forces. The force experienced by that body is equal to the difference between the two forces applied by you and your friend. The third case is if the two forces are equal in magnitude, which means equal in measurement, or equal forces are applying and acting opposite directions. The forces are acting opposite directions and equal amount of forces are applying from the both directions. What will happen? Then the net force acting on the object is 0. When we are applying equal forces in the opposite directions, the net force will be 0. Here in this case, the body does not move, it remains in the same position. A very good example is given in your textbook, page number 189. Here a game is played by the students. That game is tug of war. Here both the teams are pulling the rope in the opposite directions. If they are applying equal amount of force in the opposite directions, the rope does not move. At that point, at that particular time, the rope remains in the same position. There won't be any change in the position of the rope because both the teams are applying same amount of force in the opposite directions. Therefore, the rope remains stable or remains in the same position. These are the three cases of applying force. First one is if the two forces are applied to an object. If these two forces are applied on the same object in the same direction, what will happen? The resultant force acting on the object is equal to the sum of the two forces. When two forces are applying on the body in the same direction, you are applying a force, your friend is applying a force in the same direction. Here the net force is equal to the sum of the two forces. sum of the two forces. And second one, if two forces act in the opposite direction, then the net force acting on the object is equal to the difference between the two forces. You are applying a force in this direction and your friend is applying a force in this direction. Then the force acting on the body is equal to the difference between the two forces. And the third one is, if the two forces are equal in magnitude or the same force, same value of same measure of force is applying, equal force is applying and is acting in the opposite direction, then the net force acting on the object is 0. When we are applying equal forces in the opposite directions, equal forces are applying in the opposite directions, here the net force is 0. Okay, that's all for today's class. I hope all the concepts are clear to you.